My name is Christoph Nophut, and I'd like to tell you something about the Weihenstephaner Standards and our way to a companion specification for OPC UA. This work is supported by the VDMA. First of all, I'd like to introduce the Weihenstephaner Standards to you. The Weihenstephaner Standards cover three aspects in the classical automation pyramid. The first aspect is the definition of MES functionalities, so such like calculating KPIs, efficiency analysis, but also includes batch and article tracing and quality assurance. The second aspect the Weihenstephaner Standards covers are the description and the definition of data points which are needed for calculating such MES functionalities. And the third aspect is the communication between the machines and the MES. At the moment we have an WS protocol. It's a proprietary protocol for the transfer of the data from the machines to the MES system. At the moment we are developing and writing a companion specification for OPC UA to have an alternative communication protocol for our Weihenstephaner Standards. The Weihenstephaner Standards covers 4 different domains. The first is WSPAC, which was released back in 2005. WS Food was released in 2010. WS Bake in 2015, and the last in our domain is WS Brew, which was released in 2019. The data tag definition could look like this or in this way. This is an example of the WSPAC specification. We have a tag name. This name is unique, and we have a more common way for the operator. The name could also be in different languages. We have categories, so there's counter category. We have a closer look to the other categories in a few slides. Every tag has a unique tag number. This is from the past when with our WS protocol. So in common, every tag was defined over the tag number in the past. The data points could be read or write accessible, and we have a description of each data point. So in this example, the data point gives the number of the total packages which have been processed by the machine. In the WS protocol, it's just an unsigned number, and in OPC UA it will be an WS analog unit type. We have a closer look to this as well in the next slides. The Weihenstephaner Standards covers 4 domains at the moment, and in each domain we have a tree describing a lot of different machine classes and categories, and defining for each machine class which data point have to be delivered mandatory or which data points are optional for this machine. So in other words, we have a permutation table behind those trees, and that's an different compared to other companion specification on the OPC Foundation hosted, because if we would like to describe every single machine class, so we would have to write around about 150 different companion specifications. So we decided a little or slight different way to describe our machines in the Weihenstephaner Standards, and it looks like in this way. So we have a layered model. At the end of the day, we'd like to have instances for different machine classes. For example, a filling machine from the WSPAC domain and cutter from the WS Food domain, for example. At the bottom of every server instance is the basement of the OPC UA foundation, the OPC UA meta models and built-in information models. On top of this, we are using the companion specification for devices and the companion specification for machinery. That companion specification we'd like to use for describing meta information about the machine and organizing our WS machines within the OPC UA server tree. We're using the PacML companion specification for having the state machine from PacML. So on top of this lies our companion specification. Our companion specification only define data types and the way how to structure our machines. The gap between the companion specification and our server instances we closing by so-called WS templates. Within template we have the data point definitions and the permutation table I showed you a slide before. So we have for each domain one of such templates, and so we may be flexible to add more domains or covering more domains in the future in the same way. The starting point for every Weihenstephaner standard machine is the WSMachine type. Such machine describes which WS version is used. So this version includes the domain and the version number. At top of this, every vendor could define data point for his machine by its own. So it's possible to add a WS vendor version or a WS project version for a special product or project. The WS machine class describes which class was selected out of our domain tree. The second information of the machine type is the identification. That identification comes out of the companion specification for the machinery, which was released, or the release candidate was published in May 2020. The last information the machine type organizes are the data points within different categories. I showed you before, each data point belongs to one category, and each category has an own functional group folder, so you can compare it like a folder on your file system, and each data point are organized within such a folder. The identification block in our WS machine type is from the companion specification for machinery, and it contains a lot of additional meta information about the current machine, like information about the manufacturer or the model, as well as information about the serial number. I'd like to introduce you the document structure of the Weihenstephaner Standards and a tool, the WS Modeler, to organize and document all of our information within the Weihenstephaner Standards family. So starting point was the definition of MES functionalities. Such functionalities are defined in the document data evaluation and reporting. Each domain has its own document for such definitions, and we have the WS modeler, which we are working on. So the modeler contains all the information and definition of the data points within all our domains. It will replace at the moment, part 2 of the Weihenstephaner Standards. The modeler also containing the WS templates, which are replacing the libraries, and the templates describing the permutation table, which data points belongs to which machine class. And how this name is that already, the WS modeler is also a modeling tool, so you can create your own information model for a machine and creating configuration files for your servers. The companion specification for OPC UA for the Weihenstephaner Standards describing gives you an introduction to the OPC UA, to the Weihenstephaner Standards, and also information about mapping the WS protocol to the OPC UA protocol for the Weihenstephaner Standards, and defining the complex data type. One of those types is the WSMachine type from the last slide. Within this companion specification and the modeler, you can create a noteset file. A noteset file is a XML document and describes the information model of a machine. We also have a document for the WS protocol. The WS protocol is the current way to communicate for the Weihenstephaner Standards, and it's also possible in the future to use such protocol. The modeler is capable as well to create a config file, the BDA config file for the WS protocol. We've also have a document, the WS acceptance test. What we are writing on is an implementation guide, so it describes the workflow from your idea to a running server with the information model of the Weihenstephaner Standards.
Let's have a closer look to the WS modeler. As I mentioned before, the WS modeler is an Excel-based tool. You see different data sheets. Here, one is the definition of all of our WS data points. At the moment, there are over 400 different data points defined for all of our 4 domains. And you see the templates with the permutation table. Let's have a look at one of those data points. For example, the WS current mode data point. We see the display name. This display names is in the current language of the operator to display information on the HMIs. We have the category of this data point and the tag number from the WS protocol. Here you can see the definition of this data point, and in this example there's an enumeration behind this data point, and you can get additional information at this button. So you can see that there are different machine states like off or manual, semi-automatic or automatic are defined with this data point. We have the information about the data types in OPC UA and the data type in the WS protocol. Let's have a look at our permutation table. So we see at the top our different machine classes and our data points, and we can see which of those data points are mandatory or optional for one of those classes. We'd like to have a new model, clicking at this button and get a new window. So we can select our domain and select one of our machine class, can give them a name and create a new model. So we get a new tab with some basic information. We can see our selected domain, our selected machine class. We can give them a name. We have information about the current Weihenstephan standard version and have an information block with the information from the companion spec for machinery. We have two sections with the configuration of the WS protocol or the configuration of WS OPC UA configuration. And we have a long list with all possible data points for this machine class. All mandatory data points are already selected, and we can add some more specific data points as we'd like for our machine. It is possible to add detailed information about the engineering unit, for example, for the temperature, so you can select it in degree or in Fahrenheit. As well, you see the basic information with the description and the tag numbers. If you're already done with your configuration, you can export your model for the OPC UA or for the WS protocol communication. In addition, you can export your model to an PDF, so you have everything documented for your customers. For the first implementation of our companion specification for the Weihenstephaner Standards, we choose an simulated plant for producing chocolate bars. So this is the production line in plant simulation. Beneath every single machine are an simulated or virtual PLC with this program running on, and we can connect via your expert, in this case, to one of the packing machine in this demonstration. We can browse to the folder machines. This is the way the companion specification for machinery defines an entry point for every machine. We have the packing machine, and I've choose some of the data points which the machine is provided, so we can see that the current state is operating and the current programs are in production. We see the speed of the machine. There's actually, there's a warning in the machine that's also simulated in plant simulation. We have the counter for good and bad, good and total packages, and we see that the current article ID is a dark bar, and the next production in the queue will be a milk bar. So you can see that the developed information model for the Weihenstephaner standards are implemented in this demo.
So we can say with the companion specification for OPC UA for the Weihenstephan standards, we have an alternative for the existing WS protocol. With the self-description of the machines, we are going one step closer to an IoT and Industrial 4.0 world, which everything and every server describing itself to the world. We finished the adaptation of the companion specification for machinery, and we are going to start the release process of our companion specification in December of this year. As you saw, we are working on a modeling tool, the WS Modeler, to create easily information models for every Weihenstephaner Standards machine class. And we have done a first implementation of our information model with the ShowConnect showcase. So if you have further questions about the Weihenstephaner Standards, don't hesitate to contact me.